Hello, my name is Alex Kim, and I'm doing question one. So is A so I first said state. So null hypothesis means P1 minus P2 equals 0, and alternate hypothesis means that P1 minus P2 does not equal 0. So P1 is the true proportion of people who experience foot pain from Nike, and P2 is the true proportion of people who experience foot pain from Adidas. So for plan, the data were produced using two simple random samples, 650 from Nike and 347 from Adidas. So normal um N1 P1 equals 44, N1 times 1 minus P1 equals 606, N1 P2 equals 49, and N2 times 1 minus P2 equals 298. So since all four values are at least 10, the normal condition is met. At independent, there are clearly two independent samples, one from each brand. The researchers are sampling without replacement, so we check the 10% condition. So there are at least 10 times 650, so 6,500, and 10 times 347, so 3470 from Adidas. So 6,500 from Nike and 3470 from Adidas. So do N1 equals 650 and P1 equals 0.068, N2 equals 347, and P2 equals 49 over 347, so 0.141. So the pooled proportion of people who experience foot pain in the two sample is I got I I got 0.0933, and I used the formula, so I got z value negative 2.701. So basically I just plug in those variables, and so the desired p value is 0.006913. So conclusion, since our p-value 0.006913 is less than the chosen significance level of alpha 0.05, we reject null hypothesis and accept the alternate hypothesis. There's sufficient evidence to conclude that the proportions of people from two brands who experience foot pain are different. And B, state our parameters of interest are P1 equals the proportion of Nike consumers who experience foot pain, and P2 the proportion of Adidas consumers who experience foot pain. And we want to estimate the difference P1 minus P2 at the 95% confidence level. And the data comes from a random sample of 650 Nike consumers and separate random sample of 347 Adidas consumers. So normal n1 times p1 equals 44, n1 times 1 minus p1 equals 606, n2 times p2 equals 49, and n2 times 1 minus p2 equals 298. So independent, we clearly have two independent samples, Nike and Adidas. Individual responses in the two samples also have to be independent. The researchers are sampling without replacement, so we check the 10% condition. There are at least 10 times 650, so 6,500 Nike consumers at least 10 times 347, 347, so 3470 Adidas consumers. So so N1 650, P1 is 0.07, N2 equals 347, and P2 equals 0.14. So I use this formula to find the intervals. So and I got negative 0.013 and negative 0.127. So conclusion, we are 95% confident that the interval from negative 0.013 to negative 0.127 captures the true difference in the proportion of Nike and Adidas consumers who experience foot pain, and more Nike users then Adidas users experienced foot pain by negative 0.13 and negative 12.7 percentage points. And C, the formula of standard deviation depends on whether the data is being considered a population of its own or the data is a sample representing a larger population. So if the data is being considered a population of its own, we divide by the number of data points n, and if the data is sampled from a larger population, we divide by 1 fewer than the number of data points in the sample, n minus 1. So thank you.